Okay, so question one is, if nylon is $17 per square yard, how much would the fabric cost to make a triangular sail with a base of 6 feet and a height of 12 feet? So if I was doing this problem, I'd start off by drawing the triangle. The sail. And then I would change 12 feet and 6 feet into yards. So 1 yard is equal to 3 feet. So 12 feet divided by the 3 feet for 1 yard. So 12 feet divided by the 3 feet for the yards, and then you do the same here. 6 feet divided by 3 feet, 4 yards, 2 yards, and the 12 feet, which is 4 yards, is the height, and let me erase all this. And the 2 yards, which is equal to 6 feet, is the base. So then I move on to the area of a triangle. Area of triangle is equal to 1/2 base times height. So then you just plug in 2 yards for the base. So 1/2 times 2 times the height, which is 4 yards. And then solve this, you'd have 1/2 of 2 is 1 times 4 is 4. So you'd have 4 square yards of fabric. So it's $17 per square yard. So X equals the price. So 17 times 4 equals price. 17 times 4 is $68. So $68 would be your total price. Okay, for question 2, we're doing let triangle XYZ and triangle PQR be given. XY equals 4, YZ equals 3, ZX equals 3, PQ equals 9, QR equals 9, and RP equals 12. Indicate which of the following are true and which are false. So the first one, A, is triangle XYZ is similar to triangle PQR. So I already went through and labeled the triangles, and for the 2 triangles to be similar, we're going to use the side-side-side theorem in similarity, which is if the 3 sets of corresponding sides of the 2 triangles are in proportion, the triangles are similar. So the theorem is, so I'd have XY over PQ is equal to YZ over QR is equal to XZ over PR. So our first one is, so we have XY, which is 4 over PQ, 9, equals YZ is 3 over 9 QR is equal to XZ over PR. So 3 over 12. So these do not equal, so the triangle is not similar. So A is false. Okay, for B, you have triangle YZX is similar to PQR. So you'd use the exact same theorem as last time, but you would rearrange it to have the triangle YZX. So you would have here, you'd have YZ equals ZX equal to YX. Okay, so then you go up to your triangle. You got side YZ is 3 over PQ, 9 is equal to ZX 3 over QR, which is 9, is equal to YX, which is 4 over PR, which is 12. So you solve these. You got this 4 over 12 is equal to 1/3, and 3 over 9 is equal to 1/3. So yes, all three of these are equal. So this is a true statement. Question C, you have triangle YXZ is similar to triangle PQR. So you'd use the same theorem. You just plug these in down here. So then you would have YX, which is 4 over PQ, which is 9, equals XZ, which is 3 over QR, which is also 9, which equals YZ, which is 3 over PR, which is 12. So this doesn't reduce. This reduces to 1/3 equals 1/4. So as you can see, none of these are equal. So this statement is false. So moving on, you got D, which is triangle ZYX is similar to PQR. So you plug this back into here. ZY, then YX, and ZX. Okay? So ZY is 3 over PQ, which is 9, is equal to YZ, 3, no, it's supposed to be YX. YX, 4 over QR, which is 9, which is equal to ZX, which is 3 over PR, 12. So you have 1/3 equal to 4 over 9 equal to 1/4. So none of these are equal, so this statement is false. Question E, you have triangle XZY is similar to PQR. So you plug it into the same theorem, and you would have XZ, ZY, and XY. Okay, so go look at it. XZ is 3 over PQ is 9. is equal to ZY, which is 3, over QR, which is 9, is equal to XY, which is 4, PR is 12. So what you got here is 1/3 reduced, 1/3 reduced, and 4 over 12 is 1/3. So all these are true, all of them are equal. So this statement is true. So we are going to prove the Pythagorean theorem using this one square. Okay? So step 1 says fold a corner of the patty paper so that the crease passes through an adjacent corner as shown on the right. So you start off, go ahead and fold this. And then fold this one. Step 2 says fold the perpendicular to the first fold passing through a second corner of the square. So you can go ahead and fold this one over. Crease it down. Pop the first one out, pop that one down. And then step 3, repeat this 2 more times. So just repeat. Oh, that was not a good fold. There we go. And then last fold. And it should end up looking like this. Okay, so then we are going to says mark the right angles. With my blue Sharpie highlighter, I will mark the right angles. So here is one right angle, and just turn it. Here's the second right angle, the third, and the fourth. Okay, and then we will cut out the 4 right triangles. The last step says to show how to do the Pythagorean theorem using algebra. And what I am going to do, I'm going to place these right triangles in a form to make a square in the middle. Flip it. And that goes there. So here we are. We got this is a side A, side B, side A, side B, side A, side B, A, and B. And this is C, 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 C. Okay? So, the area of a whole square. Okay, so the area of this whole square is area equals base times height for a square. So area of this square is A plus B times A plus B. And then the area, I'm going to go in, now I'm going to do the area of the pieces. So the area of the pieces is, I'm going to get the area of the first square first. So we already have the area of a square is base times height. So you got C times C. So the area of the smaller square in the inside is C squared. Okay, and then you're going to get the area of the triangles, the right triangles. Area of a triangle is 1/2 base times height. Since there's 4 of them, I'm going to do area equals 4 times 1/2 base times height. And this is equal to 2 BH, base times height. And then we will add 2 times base times height plus the c squared. And then that equals area. So we already have the area up here. So that's the area of the whole square. So we're going to set 2 base times height plus c squared equals a plus b times a plus b. Okay, so we are going to FOIL this. FOIL. And with that we get a squared plus 2ab plus c squared equals 2. This is AB because it's base times height, so AB 2AB plus c squared. So you would find similarities in between these two, and you see that you have a 2AB, so you can subtract them from both sides, and what you get is c squared equals a squared plus b squared. And in other terms, this is the Pythagorean theorem.